So we're going to look at angles. By definition, an angle is a figure consisting of two non-collinear rays with a common endpoint. So if we look over here at our picture, we've got an angle. Non-collinear means they don't form a straight line. That's definitely not a straight line. There's got a bend over here. We know that where those two rays meet, that common endpoint B is called the vertex. So we've got point B. The sides of the angle are two rays. So one ray is BA, make sure your notation is correct, and the other ray is BC. Again, notation, make sure it's correct. And we can name angles by a lot of different ways, actually. So this angle, we can name it angle 1 because we've got this 1 in here. We can name it by the vertex, so just plain old angle B. And we can also name it using all three of the letters, as long as your vertex is in the middle. So we could say angle ABC or angle CBA as long as your vertex is in the middle. And then just to classify it, all we would say is whether it's an acute angle, obtuse angle, straight angle, or right angle. So this one is acute. If we look up here in the top right corner, we have some interior and exterior and just a little bit more practice. So we would say point U is in the interior of which angle? Well, we would say angle WXZ. We can't just say angle X because it's actually the vertex of more than one angle, so we have to be specific and say it's on in the interior of angle WXZ. And you could also say it's in the interior of ZXW. Angle 3 is the top part. So angle 3. So we'll name it. So we already said WXZ, so let's name it the other way. So ZXW. Angle 4 is on the lower half. And so we can say YXZ. So as you say it, if you can trace your pen or pencil, so Y to X to Z. Got an announcement coming, hang on. So as long as you can say the letters without having to pick up your pencil, you know that you have written or you've named the angle correctly. So we'll say YXZ. Remember that your vertex has to go in the middle. So we'll try a couple more examples. So number 1, name the angle. So vertex has to be in the middle. So we've got Y, so we can name it XYZ. You could also say ZYX. Tell whether its measure is 90 degrees, more than 90 degrees, equal to 90, or equal to an 80. Well, it is a straight line, and if you'll remember, lines are 180 degrees. And classifying it so that less than 90, greater than 90, equal to 90, equal to 180 helps us classify it. Since this one equals 180, we call it a straight angle. In other words, it's a line. Example 2, we've got an angle here. So remember that your vertex is always the middle letter. We could also just name it by the vertex. So this one, let's just call it angle P. There's not more than one angle, there's just one. Is it less than 90, greater than 90, equal to 90, or equal to 180? We know that it's less than 90, which means that it is an acute angle. If it was bigger, we would say it was obtuse. And then number 3, we've got this special little box in the corner, really teeny tiny in this picture. And so we know that it equals 90, so we'll skip straight to that one. We know it's a right angle, it equals 90, and then all you have to do is name it. So we could name it CTL, we can name it angle LTC, or we could name it angle T. So pick whichever one you understand the best. Moving on from that, we're going to add some new vocabulary. So if you'll remember when we talked about segments, we can have the same kind of theorems and postulates for angles. So if we look at angle addition postulate, it's similar to the segment addition postulate. So this is where your little plus little equals big comes into play. So your little angle plus another little angle equals the big angle. So if K is the interior of HIJ, so K is in the middle of this big angle, HIK plus KIJ typo equals a measure of HIJ. So we'll name those two angles a little bit differently. And we'll say this big thing here is angle 3. So we could say angle 1 plus angle 2 equals angle 3. So these two angles together make up the big angle. So if we look at an example, the measure of angle AOC is 70, so this whole thing is 70 degrees. AOB is 1/2 times 2x plus 20, so I'm going to go ahead and distribute in that 1/2 before I draw it into my angle. So half of 2x is just x, and half of 20 is just 10. So I've got x plus 10. And BOC is x. So using that angle addition postulate, we're going to say little plus little equals big. So little, x plus 10, plus the other little one, x, equals 70. And we'll solve it just like it's a regular equation, combine like terms. So we'll subtract 10 from both sides. Ran out of room. Divide both sides by 2, and we find that x is 30. So the rest of the information comes from plugging that x value back in. So the measure of angle BOC was just x, and we know that x is 30, and AOB was x plus 10. Well, if x is 30, 30 plus 10 is 40. So those two together make up the big angle. 30 and 40 gives me 70. So we know that we did it correctly. Angle bisector is a ray that divides an angle into two congruent angles. So it's similar to a segment bisector, kind of similar to a midpoint, but now we've got angle bisector. So bisector, remember, it's cut into two equal parts. So in this one, XZ is my angle bisector, which means that these two angles are congruent. And we show that they are congruent by drawing little arcs, and I'm also going to name them. So angle 1, angle 2. So we know that angle 1 is congruent to angle 2. We could also name those angles a little bit differently. We could say WXZ is congruent to angle ZXY, but angle 1 and angle 2 works as well. So over here, we've got FG, it bisects EFH. So remember in geometry, we want to draw as many pictures as possible. So since it is bisected, we've got two equal parts. If GFH is 1/2 of 10x minus 20 and EFG is 3x plus 25, we're going to find all of these things. So again, I'm going to distribute in that 1/2. GFH is going to be 5x minus 10, and EFG is 3x plus 25. So remember, bisect means two equal parts. If I know that these two angles are congruent, I know that 3x plus 25 can be set equal to 5x minus 10, and now we've got just a simple equation to solve. So we'll subtract 2x from both sides, add 25 to both sides, and we find that the value of x is 35. And then to find the rest, all we have to do is plug that x value in. So sorry, I'm looking at my work. I'm seeing a mistake somewhere. Oh, I wrote a 2x instead of a 5x. Okay. All right, so let's take a step back. So if I subtract 5x from both sides, I end up with a negative 2x. And then I'll divide both sides. I'll do that right. Did that fix my problem? Yes. All right, so divide both sides by negative 2. And we find that x is 17.5. All right, then we'll plug that value of x into my equations to find the rest. So GFH, I'm going to plug in 17.5 in for x. We'll have 5 times 17.5 minus 10. We get 77.5. So we should get 77.5 for EFG. We'll make sure and check it. So 3 times 17.5 plus 25 is 77.5. Which means those two together, EFH, is 77.5 plus 77.5, which gives me 155. And then it's asking me for IFE. So if I know that this set over here is 155, this 155 plus whatever this angle is makes a straight angle. So if it makes a straight angle, I know that this whole thing is 180. So whatever left is this angle over here. So 180 minus 155 gives me 25. So obviously, this angle over here is not going to be 25 degrees, so obviously the picture isn't drawn to scale, because that is definitely possibly a right angle, borderline, maybe acute, maybe a little bit obtuse. So, but definitely not 25 degrees. But the algebra worked, so we're good. Couple more examples. So find x. So in this one, we've got that box, which means that we have a right angle. So we know that these two things together make 90 degrees. And we'll use our angle addition postulate to say little plus little equals big. So 4 plus 6x plus 3x plus 5 equals 90. So I'm going to help you set all of these up. I'm not going to spend the time to solve them because I'm really hoping that you're comfortable combining like terms and solving for x. So that's how you set that one up. And then you can solve it. You can check back on the notes key, make sure you did them right. So example 6, IR bisects HIJ. So since it bisects, I know that I've got two equal angles. HIR, the measure of angle HIR, is 6x minus 5, and RIJ is 43 minus 2x. Find the measure of angle HIJ. So that means in the end, we're going to plug our x value back in and solve for HIJ. So this one, since we got two equal pieces, two equal angles, my equation is going to be those two angles set equal to each other. And then we would solve for x. Again, I'm just going to set them up. You can check back with the key to see those solved. Example 7, KM, ray KM bisects JKL, and the measure of JKM is 12x minus 9, find x. So first things first, draw in our picture. So KM bisects JKL. That means we got two equal pieces. We also see that we've got that square in the corner, so we know that whole angle is 90. So it's a right angle. And we know that JKM is 12x minus 9. So just looking at the picture, it doesn't seem like we have enough information. But we know that these two pieces are equal because it was bisected. So if this piece is 12x minus 9, this piece is also 12x minus 9. And we were not told in words that this box makes it a right angle. So we have to know a little bit about the picture in order to solve this one. So using that information, we'll say little plus little equals big. So my two littles end up being the same. So 12x minus 9 plus 12x minus 9 equal my big piece, which is 90. Example 8 uses the same picture and the same information. So BA and BC are opposite rays, which means we've got a straight angle. BF bisects CBE and BD bisects ABE. So all of this information we might not need to solve the problem. So if we look at A, if the measure of angle EBF is 6x plus 4, and CBF is 7x minus 2, we are trying to find the measure of EBC. So we're trying to find this big angle. So now let's go back in the instructions and see which information we need. So BF bisects CBE. So BF, well, that's right in the middle of all the information that I've drawn. So since it's bisected, that's probably helpful information. We know that those two things are now equal, and we can set up our equation. We can solve for x, and then we can plug it back into the equations to get the measure of angle EBC. In B, it says the measure of angle 2 is 5x minus 7. And the measure of angle ABE, so ABE, so this whole thing is 7x plus 13. Find the measure of angle 1. So again, we're going to solve for x and then we'll plug it back in to find angle 1. So we'll go back in our instructions and find the important information. So BF bisects CBE, so we don't really have anything over here, so that's not important. But BD bisecting ABE is important. So bisect means two equal pieces. If we know angle 2 is 5x minus 7, we also know that angle 1 is 5x minus 7. We have a little plus little equals big, so that's what we'll do. So we'll have 5x minus 7 plus 5x minus 7. We could also write it as 2 times 5x minus 7. It's whatever you're comfortable with. And it's equal to the big piece, which was 7x plus 13. C says the measure of angle 2 is 3x plus 4. EBF, so EBF is 2x plus 6. And ABF, so this whole thing, is equal to 11x minus 34. Find the measure of angle 3. So we have a little piece and a little piece and a big piece, but we're still missing this little piece over here. So we'll go back up to our instructions and see if any of that is relevant. So BF bisects CBE, so we don't even have a CBE, so obviously not. And we know that BD bisects ABE. Well, that could be useful. And it's useful because we know angle 2, which means we also know angle 1. And now we can say little plus little plus little So add that extra little equals big. Combine like terms and solve, and then plug it in to find the measure of angle 3. Last one that we'll set up, the measure of angle 1 is 3x plus 10. The measure of angle EBC is 9x minus 35. Find the measure of angle 4. So again, once we solve x for x, we're not done. So let's go back up to our information. So BF bisects CBE, so that could be helpful. Maybe. And BD bisects ABE, so that also could be helpful. I'm going to write them in different colors just so we don't get confused, because they're not all equal to each other. So if we're looking at this, we're missing some information for angle 2, but we can fill it in. We know that it's going to be 3x plus 10. And so it wouldn't be helpful to set these equal to each other. It looks like they could be equal, ABE and EBC, but I don't know that for a fact, so I can't use that information. And somehow I've got to figure out angle 4. So this one's pulling out all the tricks. We should, at this point, know that ABC is 180 degrees because it's a straight line. So now we have enough information to say my little angle plus this little angle equals 180. And then you would solve for x, combine like terms and solve for x, and then you would figure out angle 4. So again, to get the rest of those solutions, make sure you check back to see the notes key.